Hey guys, so if you have been following along this video series, you might have noted that last couple of videos was dedicated to AWS Mobile Hub. And in the first video, we created a web application and hosted it on S3 bucket and serve it through a CloudFront distribution. We could do it quite easily with AWS Mobile Hub console in a couple of clicks, right? And in the second video, we added authentication or user sign in and sign up capabilities. There we use Cognito user pool. Today, we are actually going to create an application. We are going to create a to-do application where a signed in user can do all the CRUD operation, create, read, delete, and update, right? And we are going to add 3 levels of security in this application. Well, first is the user sign in. So he will be signing against a user pool. And the second level is at the API Gateway level. We'll be using API Gateway as the proxy for our backend services. And at the API Gateway level, we will add IAM authorizer. So that's the second level. As a third level, we will add it in our database or at the database level. We are going to use Dynamodb. In the Dynamodb, we are going to add row level restriction. Now, since the user is authenticated against a Cognito user pool, he has a Cognito user ID. This Cognito user ID will be used as the partition key of the Dynamodb table. So no one else can read anyone other than his to-dos. So that's quite secure, and that is one of the recommended way to implement SaaS application when it comes to a multi-tenant application. Although this is not a multi-tenant application, those concepts can be used. So that's what we are going to do. And if you like these videos, please thumbs up and subscribe and share this with your friends. So we are going to switch into the other screen and go ahead with the setup.
All right. Now, before we start today, I want you to know that there's a written version of this video at awsvideos.com. When you visit the site, you will see there's a list of tutorials. And building a secure to-do application, this title belongs to today's video. When you click View, it will load the details. And when you scroll down, you will see this is a step-by-step guide with coding example as well as screenshots. You can use this to copy-paste code or to get to know about theories, if you will. Okay, now I am at the slides. This is the diagram. So last couple of videos, we used AWS Mobile Hub to host a web application on S3 bucket and serve it through a CloudFront distribution. And also we've added authentication or user sign in and sign up with Cognito user pool. Today, our sole focus is on calling backend services. Since we are developing a to-do application, a user can log into the application and make, create, read, delete, update calls. Those calls will be intercepted by an API gateway and proxied to a Lambda function. So this Lambda function has logics to talk to the database and get to-dos and send back to the user or perform any operation that is requested to. In addition to that, we are going to implement 3 levels of security. First layer of security is at the authentication layer, which we have already done. And the second layer is at the API gateway level. And also, we will have security implemented at the database level. We will see it in much more details today during the tutorial. Okay, the codes from last 2 tutorials, I have uploaded it into this particular GitHub repository. So first we need to get a clone. So I will click clone and copy the URL and come back to the terminal. You see I'm at the desktop at the moment. I will type git clone, the URL space, my app, the folder that I want to clone this. Let's give it a second. Okay, it's completed. Now I wanted to open it in my IDE. So I'm using Visual Studio Code. So I will type code space dot. You can use any preferred IDE. Now in the source folder, you will see the app folder. And inside a folder, you will see two components, auth and home component. In the auth component, we have our login page. So we are using a directory from Amplify library. And in the home component, we have our to-do application. Now at this very moment, we cannot run our application, mainly because in the last two videos, we have linked it with AWS Mobile Hub. So in order to get this thing working, we need to go to Mobile Hub and create a project. So I'm choosing the platform as web and cloud enable your existing application and click start. Now I will give it a name, say to do app, click next. All right. Now it will ask us to install the AWS Mobile CLI globally, which we have already done. And also it has given us the code to link our front end with the backend we just created. So this is the one that we want to do. Now before that, guys, if you haven't set up your credential, you can just follow along this particular link and then have them set up. Basically, you need to create IAM user with admin permission and then use AWS mobile space configure on the CLI and then add the access key and secret access key. Okay, now I will open up the integrated terminal and paste in the code that it just gave us. Okay, source directory is src and the folder of the distribution directory is at dist slash the folder name that I've given, it is my app. The build command is the same and also start command is ngserve. Let's hit enter. And now it will connect our front-end application with our AWS mobile backend. Okay, now that the linking is completed, we can go back to the AWS Mobile Hub and click next in the wizard and then click done. Right, as you can see, it has already enabled the hosting and streaming as well as messaging and alerting. Now we want to enable user sign-in as well. Click user sign-in and email and password, create a new user pool. We'll use username to log in and then the password length and all as default, and let's create the user pool. So it will create the user pool where our users will be stored. Click on the banner and it asks us to integrate it. So let's pull the changes that is just done. Let me type AWS mobile pull. Now it will pull down all the configuration changes that we just did at the AWS mobile console. Okay, say yes. We can cancel it and refresh it. Okay, great. Now actually we can run our application because we have added the hosting and also the user sign-in. In order to run it, we can type AWS mobile space run. This will connect our front end with the back end as well as it will spin up the Angular inside a local server. Alright, so let's go to a browser and let's type localhost 4200 and press enter. Should load our application. Yes, so this is what we have done last time. So I wanted to sign up and let me type the username as mjson and password, the phone number. You can click sign up. Then it will send a code to your email. And I just received the email and my username is mjson and this is the code, and I will click confirm. Then it will ask me to log in. Again, I will type the username and the password. Click sign in. Okay, now I'm registered in the user pool and I can log into the application. Great. So this is our to-do application. I know it's ugly, but if you type eat, sleep, code. So these three to-dos, you can see it will add it in the list. You can complete it, you can delete it, you can do these basic things. So at this moment, we haven't yet connected it with the backend. So in order to connect it with the backend and persist this information in a database, we have to create a database. So let's go back to our AWS Mobile Hub. And this time we are going to enable No SQL database. Click plus, click enable No SQL. And then you can click add table. When you click add table, it has given me three options. You can use an example, or you can do it from scratch, or you can use a wizard. I like this wizard because it's quite informative. Click this one and I'll say yes, let's get started. The first question it's asking me is, would you like users to read each other's data? So in our case, it's a to-do application, so we don't want anyone else's to read my data. So I will say no. App users will not have any access to other users' data. You'll see the permission is set to private in this case. Now, depending on the scenario or the application that you develop, this will change. For example, let's say that you are developing a blog. In the blog post that one particular user post can be read by everyone else. So in that case, the option should be yes. Then it will ask another question. Would you like users to be able to update and delete each other's item? Well, in the case of blog, no, because I don't want anyone else to edit my blog post content. So when you click no, the permission will be set to protected. Now suppose there's a shared document or it's a Google Doc kind of application. In that case, where everyone will have access to everyone else's data and also edit it. So in that case, the both answers is yes, and the permission for the table would be public. So you can handle any type of application with these two questions. Actually, you can customize them if you want. Now I will click no again because I don't want any of that. And then I will click save and continue. Okay, so now it's asking for a name. To my table, I will say to do items. Now, what other attributes do I need? You'll see there's this user ID that has automatically filled in. So this is basically, since our table is private, Mobile Hub added this field by default. So this is the Cognito user ID of the signed in user. So this will be checked at any given point of time when querying the data. So what else do I need? I need to do ID, and then I need to do itself, the name or the value, and also I need the status. So the type of to do ID, of course, it's string, and these are also string. I will click save and continue. At this screen, I am asked to select the sort key. Well, the partition key is user ID. And do I need a sort key? Yes, I do. I will select the to-do ID as my sort key because then I can make queries like delete this particular to-do belonging to this to-do ID of this user ID. So those kind of queries can be made. So that's why I selected the sort key as the to-do ID. And do I need any other indexes at this moment? Maybe I can add an index on my status, but I'm not going to do that at this moment, so I will skip it and then click save and continue. So this is the preview. It looks okay to me, and I will click save and finish. Okay, now it has asked me to refresh the view. Maybe I did not refresh it earlier. Okay, now I'm back at this particular state. It's okay. So I will select again no. So it's private and click save and continue. Why did I just give? I said to do items. And to do ID, to do status, all string, save, sort key as the to do ID, skip and save and continue, save and finish. Okay, great. Now it has again prompted me the banner. Okay, now you need to pull down the changes. Let me do that immediately. AWS Mobile Pull. Now it will pull down all the configuration changes that I've done onto my database. Hit yes to sync. So once you sync it, you can actually go to aws-export.js and view all the information that you just set up, Dynamodb table name and all that. Okay, now I want you to go to my diagram here. So we actually have set up the Dynamodb. Now I want to set up my API. Well, I can use the Mobile Hub itself and click Cloud Logic and enable it. But as of now, the Mobile Hub console does not allow me to link a table with an API. So basically, in the CLI, it enables me to connect a table and create a REST API onto that table automatically through the CLI. So I'm not going to use the console, but instead I'm going to use the AWS Mobile CLI. So let's see, I will type AWS Mobile. Now when I type AWS Mobile, it will list down all the commands it has. You'll see as under AWS Mobile features, it has Cloud API. So I will show you what did I just meant. Let me type AWS Mobile, Cloud API, enable, and I will add a flag -- count. When you click this, it will ask me a question. Do I need to create an API, a new one, or else do I want to create an API from an existing table? So this option, you don't get it in the console. So that's why we chose to do it in the terminal or the CLI. Let's click this one and it will suggest me which table. It's to do items table. Click yes. And then it will ask restrict API access to signed in users. Yes, I want only for the signed in users to access it. That's it. So let's give it a minute. Okay, done. Now it has created the API to my table. Now let me show you where it has created it. If you go to AWS Mobile.js folder, you can see there's a folder called backend. Under that, you'll see Cloud API, then the to-do items, the table name, and there is this app.js file. This file, you will see it's an Express.js application. That's interesting. And in this Express.js application, it has routes to do items, getting all the items with this route, and getting a specific item here, and you can put or update an item, you can create an item. All these routes are there. Now it's a Express application. This is interesting. As you guys already know, the Lambda is not suitable for long running processes. Now this Express application or the Express server has to be a long running process. in order to host it inside the Lambda, we need a helper or a middleware. So that's why they have included this particular library or this AWS Serverless Express library in the lambda.js file. Now this acts as a middleware. So you can see in this particular file, so it has the handler function. Now this is the function that API Gateway will call whenever event is received, and it will call this with the event data. Now API Gateway send the event data in terms of or in the format of JSON. But for an Express application, it accepts only the HTTP request, right? So in order to convert this event JSON to HTTP request, we are going to use a middleware called AWS Serverless Express. And the second line, you can see it has required this app.js file, and then we'll use this middleware as a wrapper to the Express application to convert JSON to HTTP request. And also, once the response is generated in terms of HTTP response, it will convert back to the JSON response before it sends back to API Gateway and then onto the caller. So that's what this does. And there's another thing that this middleware does. When the event is received to the API Gateway and onto the Lambda, it will check whether the Express server is running. If it is not running, it will run the Express server inside the Lambda function in a local port, and it will make sure that the server is running. If not, it will spin up again. All right. Now, let me go to my mobile hub and do a refresh because I faced a problem earlier. Let's do a refresh again and make sure our user sign in and database enabled. Okay, now we need to sync our API changes to the mobile hub because we did it in the local machine or through the CLI. So we need to sync it. In order to sync that, I will type AWS Mobile push. This will sync changes, all the local changes, onto AWS Mobile Hub backend. This will take a couple of minutes because it has to create the CloudFormation stack and run it and do all that things. So let's be patient and give it some time. Well, I might also fast forward this step. Okay, now our local changes are synced with the AWS Mobile Hub console. Just to check that, let's go to Mobile Hub and refresh it. I should see the Cloud API is now enabled. Very nice. Now we have all the resources we need: database, Cloud API, user sign-in, and also hosting. Right. In order to use these services, we are going to use AWS Amplify library, which we have configured during last video. If you guys don't know it, just go to the last video and check that. Let me go to our home component. In the home component, in the HTML, we have this add to do. Now, in fact, I'm going to run the application. I will type AWS Mobile run. This will also take a little bit of time because it's the first time it is connecting with all these services. Give it a second or couple minutes. Okay, now it's connected. Well, it took me about 2 minutes. The first time is always painful. All right, so let's see. And right, you can see there's a button add, and I have attached a event handler. Let me go to HTML, and add to do is the event handler. So add to do is the function that it will create the to do with the ID, and it will get the text that I type in and also status as to do. Then it will push it into the to-dos array. And then I have commented out this code. So this is basically talking to our backend API to this particular path with the payload as a post request. So I'm going to uncomment it. And this Amplify service, I got it through AWS Amplify. And we are executing an API level operation. So that's what we have added API and the post request. So how did we get the name of the API? This name is wrong. Let me show you the place where we can get the name of the API. Well, as usual, the common place for the configuration is aws-export.js. And when you click that, you will see under the key name of AWS Cloud Logic Custom, the name is to-do item CRUD. Copy it, come back here, and instead of this one, paste it in. And also the path, go back here. As for the path, it is to-do items. Right. Now let me replace it with to-do items, and the payload is, well, it's fine because our attributes are to-do ID, to-do, and status. Okay, now it should post this item. Let's check whether it works. So I'm going to open up and inspect element so I can observe the request. Let me just tag it onto the right side. We'll go to the network tab, clear the screen. I will type eat and click add. Let's see, the request is this one. Okay, I got a 200 level with the post call succeed. Now this is persisted in the Dynamodb. Just to make sure, let me go to AWS Mobile Hub and go to resources. And there you will see all the resources of our API backend. You'll see the Amazon Dynamodb table, and you can click the link and that will directly take you to the table. Okay, so this is our table, and let me go into items. I should see a record. Here we have. We click that. Now it is inserted properly. Now let's change the status to do to complete. Let me go into our front end, and when you click complete, so let's check what is the event handler we have attached. Complete is complete to do action. So let's go to this complete to do handler. And in that case, you can see it changed the status to complete and create the payload again. And let me uncomment this one. Again, I'm going to use the put request here because I'm going to update it. And the API name is to do items CRUD. URL is the same. And payload is payload. Right. Now let's refresh it. Well, you see, I lost that particular item. So that is because we are not loading the items at initial at the application startup. We will handle it in a bit, but now let me just type another to do sleep. And you see it's nicely added or completed successfully, and I will click complete. When I click complete, you'll see there's a put request is also completed. It is successful. Just to make sure, I will go to Dynamodb and let me go to this one, sleep. It is completed. Now let's handle the other problem. So that is when refreshing, it won't load our items. You see it's not loading anything. Let me go back to our ng on init. So I will remove this empty array. Instead of that, let me uncomment this code. So it's basically going to load to-dos. In load to-dos, basically it is going to send a GET request to our API. The name has to be changed. to this, and also the path has to be changed to to-do items, and it will get the items and it will assign it to this particular array. So this is the array that we are showing here. Okay, let me just refresh it. So let's see if it is showing any information. Yes, you see it has loaded it, and this is the GET request. This is the GET request. Here we have received the information. Okay, I hope you guys understand how this works. Now let's step back and see how we have implemented these two levels of security. We know we have already implemented the authentication layer so that the security layer 1 is complete. What about the second layer of security? So I said it is added to API Gateway. Now let me go into AWS Mobile Hub, and I have selected resources. So let me just go to Amazon API Gateway. So this is our API, and if I go into the API, and I can check what is the authorizer that I've set up. Now this is our endpoints. Now let me click this particular endpoint, and you'll see as the auth attribute I have set AWS IAM. Now this instruct API gateway, anytime you will get a request, always check the IAM credential. And how did this request sends the credential? Because that happens through a process called SIG-WiFi signing. So thanks to the library, which is Amplify library, and it has saved all the tokens in the local storage. So it will forward all the tokens like ID token. Let me see it. See, you have the ID token in the local storage. It will use this token to exchange the credential with identity pool. You can actually see the explanation in the first video. So basically it will create these ID tokens with the credentials, and those credentials will be sent over with each and every request as a signed request. So when those signed requests reach the IAM or reach the API gateway, it can extract the credential. With the credential, it can extract the role, and with the role, it will go into the policies of that role and make sure that this particular request can invoke this URL path. So that's how the second layer of security is established at the API gateway level. So what about the third layer of security? Now, so that is also happened through the IAM credentials. So when the request is reached out to the database, it will check the policy again in the role that is assigned to that request, because when the user is signed in, we will assign the authenticated role. Now let me show you that as well. Now I am again in the resources section, and if I go to identity and access management role, you'll see there's a role called to do auth. Let me click that. That will open up the IAM management. So this is the role that will be applied to any user who is successfully authenticated. Now under the permission tab, you'll see all the permission that it has attached in this role. For example, let me show you the cloud logic or API gateway policy. I will click edit policy. Oh, I should not click that. Anyway, JSON policy, JSON. So it says, okay, allow this user to execute the API. The effect is allow, and the resource is our API gateway ARN. So the signed in user can execute API gateway. Now I will go into a different policy. So that is related to our No SQL database. Let me open this up. And you'll see in this particular policy, it's a little bit special. Now it says, okay, allow the user to do this action on the DynamoDB. He can put, delete, update, write all that action onto this particular DynamoDB table, which of course the our DynamoDB table, and then it has a condition. For all values, make sure the leading key is equal to the Cognito user ID of the signed in user. Now this leading key refers to the partition key. So let me show you. I open the item in the DynamoDB table, and you'll see this user ID is the leading key, or the partition key is our leading key, and it will always check whether the value of this leading key is matching with whoever the user's Cognito ID, right? So that will make sure no matter who the user is, he can only access only his to-do items. Where's my IAM role? Here it is. So it will make sure anyone else's cannot access anyone else's data, but only his information. So that's how the third layer of security is implemented. I hope it's clear. So that's what I want to explain in this tutorial. So if you guys have any questions, please feel free to put a comment. Right. Thank you very much, guys. I hope you guys enjoyed it. Please, again, if anything is not clear, just let me know. I will do my best to make it understandable. All right. Thanks. And I'll see you in another video.